Hello and welcome to m252, Calculus 2 here at Cañada College. My name is Lapuz. In this video we're looking at checkpoint 5.3. This is coming from section 5.1. It says to consider the sequence 5n squared plus 1 all divided by e to the nth power and determine whether or not the sequence converges. And if it does converge, find its limit. So the idea behind a sequence converging is simply taking the limit. So let's take the limit of this sequence. That's the limit. And by limit I mean n goes off to infinity, because the sequence technically goes from n at some value, usually 0, sometimes 1, and sometimes other values. And seeing what happens as it goes off to infinity. So if you let that go to infinity, we got 5n squared plus 1 over e to the n. So if we let this go to infinity, we're going to get infinity over infinity, which is going to be an indeterminate form. And we can do a variety of things. We can just say that e to the n goes to infinity faster than any polynomial, so this is eventually all going to go to 0, or you can use L'Hopital's rule once or twice or something like that. So let's do L'Hopital's rule, and I'm going to call it, I have a conditional equal sign here that has a B for Bernoulli, who actually kind of discovered L'Hopital's rule. And we take the derivative of the numerator, so this is going to be 10n, and the derivative of the denominator. And we'll see that this is infinity over infinity again, so we apply the rule one more time. Limit as n goes off to infinity, and then we get 10 over e to the n. And the point is that this is a constant in the numerator and infinity in the denominator, so this will eventually go to 0. So we can say that the limit goes 0, and therefore the sequence converges. The fact that it is equal to one particular answer, and since we know that one particular answer, we know that it converges to that particular answer, which is equal to 0. So that's it. We got our sequence converging to 0. I hope that helps.